Okay, welcome back. Hopefully spring break was good for you. And here we are with Honors Pre-Calculus, okay, for the week with Monte. Now, Honors Pre-Calculus, let's take a look. I think we're about to wrap up a unit, okay? So let's take a look at this unit here. Yeah, analytical trigonometry. So we'll call this Unit 5. Okay, Unit 5. Wrap up. All right, welcome back. So, Unit 5 wrap up for pre-calculus. And don't forget, we have a Teams channel. And in the Teams channel, you can find all these videos posted in our stream channel. Okay? Alright, so let's get started. Obviously, the first thing we're going to do is find the internet. We find our digital tools. We'll find Clever. Go to Blackboard, and we want to find pre-calculus. In the announcements, you will find the links to get to Math Excel plus these video posts, if that helps you to work forward. Alright. So hopefully spring break was good to you. You're rested and ready to go. Okay, so the first week, and then the second week, and then the third week. Now, I want you to remember, quizzes is all we need. You don't have to take the tests because of all this virtual learning unless you want to. That's totally up to you. Also, don't forget, from a time perspective, these do take time. Many of these problems do. Also, I'm getting advice on where we're headed next. Do we have to do polar coordinates? Do we have to do matrices? Do we have to use statistics? And then the most important thing we do is get ready for calculus for next fall. Okay, so for sure we're going to focus down here, but I'm getting advice on what they're doing in the live classes in this area. All right, this normally I try to advise, give problems for 2 assignments. Okay, these are the last 2 assignments, but they're very important mathematically. The law of sines and the law of cosines. Trigonometry focuses on the right triangle, SOHCAHTOA, right? Sine, cosine, and tangent. Well, not everything in the real world is a right triangle. So how do we work with non-right triangles? And that is the law of sines and the law of cosines. Once I saw that this was so involved, I created a cheat sheet. And our cheat sheet is, and I'm sending this in an email to our pre-calculus students, and I'm mailing it home to you. So look in the mail the next couple of days for the law of sines cheat sheet and the law of cosines cheat sheet. Now, if we had time to derive these, all these are manipulations of Pythagoras. A squared plus b squared equals c squared. But there's not a right triangle, so we need what's called a fudge factor. Okay? And it's just plug and chug. So it's not a difficult task, but the understanding of, because it's not a right triangle, we have to adjust. We have to adjust this letter C, this angle C. And this is the adjustment factor to create a right triangle. All right? So let's get started on the law of sines. Okay? See what question 1 looks like here. All right. Determine the value. Okay. Determine the value of A, big angle A. Select the right choice if necessary. Fill in the box. Round to the nearest whole number. Well, to find angle A, that's easy because all triangles are 180 degrees, right? All right. So let's just move this up. Clear the canvas and 180 minus 80 minus 45. 180 minus 125, 55. Let's try 55 over here. Good. Wish they were all like that, okay? Determine the value of A such that. Okay, so now we have this thing called the law of sines, okay? And the law of sines states that angle A to side A creates a relationship that is proportional to angle B to side B, angle C to side C. That's all it is. So once you have one of the relationships, the 4 to the sine of 20, then we know that that proportion, that relationship is exactly the same as the sine of 52 to 9 and corresponding C to C. All right, so let's go do this problem. Okay, and what do we have? We have this, stop it. We have this relationship, okay, and we need A. We need A, okay, but we just calculated this. So I'm just going to use this one here, 80 to 5, 5 to 80. Doesn't matter if I go sine to 5 or 5 to the sine, since I want this on top. Okay, so let's move this over. And we got a 55 to the small a. And we have 45 to the small b. But here's the one I know. The 80 degrees goes to the 5. So 5 goes to the sine of 80 as a goes to the sine of 55. Okay? So we're using this cheat sheet, trigonometry, the law of sines. Okay? Alright. So now let's just do some math here. Okay? We need a bigger sheet of paper here. Okay? So we just cross multiply, right? That to that, that to that. So 5 sine 55 equals a sine 80. Sine of 80 is just a number. Divide by sine of 80. Divide by sine of 80. Boom, boom. Okay? So, since you have a fancy calculator, let's grab the fancy calculator. Anytime you grab your fancy calculator, make sure you're in the correct mode. I am in degree mode. So, I'm going to go 5 sine 55 close divide by sine 80 close. And then round to the nearest 2 decimal places. 416. Let's try 4.16. 4.16. Cool. Now determine B. Okay, so now we've done part of it. Let's bring this back. Okay, so we did, what was it? A equals 4.16. 4.16. So now we got to do it again. And once I start, I'm just going to use that one every time. So 5 sine 80 as B goes to the sine of 45 degrees. Okay. Again, we cross multiply, giving us 5 sine 45 equals B sine 80. Again, divide by the sine of 80 because that's just a number. Grab our calculator. 5 sine 45 close, divide by sine 80 close equals 359. 3.59. Cool. Next question. So that's the law of sines. There's going to be 8 questions. Let's just make sure we're doing the law of sines. Okay, 45 60s and a length of 8. The shortest side with angles. Okay, so shortest side, longest side. Okay, so the shortest goes with the smallest angle. Okay, if you don't recall that from geometry, think of this. Okay, so let's go a 40 degree, 40, 65, 75. So 40, 65, 75. Okay, and across from the 40, this will be the shortest, this is the median, and this is the longest. The bigger the angle, the bigger the side, right? So 40, 65, and something has length 8. And 75 degrees has length 8. The shortest side of a triangle with angles has length 8. The shortest side. So I think they meant that. So the 48 goes to sine 40, and then we work from there. Okay? Alright. So now what I'd like to do is let's save this and just look at the law of cosines if you get ahead. If you don't get to that this week, that's okay. Because as you saw, we're 11 minutes in and I only did one problem. Okay? Law of cosines is even longer. Okay? Now, what I want to do is introduce the idea of side angle side. Okay? Alright, so side angle side. Okay, I'm going to draw a triangle. I'm going to copy this. Okay, and we have a 5, a 7, 97, and C. Big A, big B, big C. Okay, so this is small c. Now, Pythagoras told us a squared plus b squared equals c squared, but that was only for right triangles. Okay? This is not a right triangle. We need a fudge factor. So now, we're going to flip this around because we need this fudge factor. C squared is equal to a squared plus b squared minus a fudge factor. That's all it is. Okay? We need a fudge factor to create a 90-degree triangle. Okay? Fudge factor to imitate 90 degrees. Now, we're not going to go through the proof. It can be done. You can Google it. Okay? And that fudge factor is this. A squared plus b squared minus 2ac 2ab 2 times a times b times the cosine of angle C. And then we're going to grab. Okay, so a squared, so I'm just going to use this one. I always just use the same one because the C is the angle that we have. So whatever angle you have, that's the side you're looking for. Side, angle, side. Okay, so C squared is a squared plus b squared minus this fudge factor, 2 times a times b times the cosine of C. And here's one that actually goes through it, and the reason that I have this one is because I think it's important to go a piece at a time. So many students make mistakes right here. Okay? Do a piece at a time. Don't get in a hurry. Don't try to put it all into your calculator at one time. Okay? So, now let's work on this. The first thing you heard me talk about was side, angle, side. So we got a side, we got a side. A squared plus b squared. What are we looking for? We're always looking for the side opposite, the side across from the angle. Okay? So, side across from the angle, and that's the angle we're using. Okay? Alright. So now, Let's try this problem. Okay. Make sure we're doing it right. One possible solution. There are two possible solutions. The measurement of the solution to a certain side are as follows. Kind of funny they asked us that on the very first one. Okay, so c squared equals a squared plus b squared minus 2 times a times b times the cosine of 97 degrees. Okay, so now piece at a time. 25, 49, 35, 70 cosine 97. 74 minus 70 cosine 97. Now, this is where we can get into a little bit of a pickle. So let's try this. 70 cosine 97 minus 8.53. So you see how it's minus a minus 8.53. Okay? So we have 75 plus 8.53. I want to be as accurate as possible, so I'm going to use the calculator. And I'm going to go times negative 1. So now I have a positive plus 75. Now I need the square root. Okay, so c squared equals all of this. The square root of c squared is the square root of 83.53 dot dot dot. Second square root of our answer so that I have it as accurate as possible. 9139 to the nearest tenth. 9.14. Okay, so now 9.14. Okay, now you're going to notice it wants the angles. 9.14. So now let's redraw this. 5, 7, 97, 9.14. Well, to get the other angles, now we're going to go back to use the law of sines. So here's the relationship we want, that to that. So we want angles. So the sine of 97 goes to 9.14 as, we'll just count this as b. Sine b goes to 5. Okay? Cross multiply 5 sine 97 equals 9.14 sine b. Divide out the 9.14s, divide out the 9.14s. We're happy because that goes away. We're not happy because it's a long problem. Okay, so now sine b equals 5 sine 97 over 914. Let's get this out of the way. 5 sine 97 close, divide by 9.14, 0.5492. Okay, 0.542968. But we need b. Okay, we need this b. In order to get the b, that's the arc sine of 0.454296.8 dot 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 dot. So now, second inverse sine of the answer, 32.8. 32.859 around the lengths, and the angle measures to the nearest degree. Nearest degree, 33. Let's go 33. Okay, so now we got a 33. Then 180 minus 33 minus 97. 180 minus 130, 50. 83, 99. Yep. Okay, now there's only one possible solution. There are two possible solutions. Okay, now this is called the ambiguous case. All right, if you have two, that's the ambiguous case, and it's got this little dangle thing, but let's just assume this one, since it's the first problem, it's going to be a simple one. So C, 9.14, A was 50, B for 33. Your second two answers are correct, but the first one is incorrect to the nearest tenth. To the nearest tenth, Monte. Okay, all right. Now before we go on, view an example. Okay, so we have the Pythagorean theorem minus the fudge factor. Calculate. Yeah, there's what's called an ambiguous case. Once in a blue moon, you get this one. Okay, we're 21 minutes in. That's why if you only do one of these assignments a week, that's awesome. Okay, because there's a lot going on. They take time, and if you type them wrong, 1 decimal point, you're off. So look for this in the email. Look for this on in your mailbox. And now that I talk about it, let's make sure we post this here also. Okay, so I'll do that next. We'll post this cheat sheet. Have a great week. Pre-calculus as we wrap up Unit 5, Analytical Trigonometry.